Hello, good morning students. Today we are going to discuss about new chapter, new topic, electric potential and capacitor. In a previous class we discussed about electric potential. Today we are going to discuss about capacitors. So now what is our plan today? That recall the capacitor is circuit component that can store charge. We understand about today capacitors, dielectric medium, how to the made of the structures of capacitor, number capacity consistence of the two plate of the sides, and when the charge one side is positive and negative charge, how do they work? Understand about the capacitors of the charge store in it and their potential difference across capacitor, and we understand the diagrams of the capacitor, symbol of diagram of the symbol of capacitor, as well as when the conducting medium between two plate, two negative plate and between negative plate and positive plate, as well as we discuss about the dielectric when the capacitance between two plates. Now even also we learn about to be the how does the get the capacitors connect in the circuit. Another one is a two side of the capacitor. We are even a student understand about two side of the capacitors are connected by circuit with no other matter or source of potential difference. The capacitor will discharge. So we learn about the all the concept relevant to capacitors. Let's we start from the topic about dielectric. Dielectric means what? The dielectric is an insulating material um, that have no free charge carrier. So electrical conductivity of ideal dielectric electrical zero. It means that I'm talking about with the insulating material. So as for the insulating material, like examples, I'm taking glass, mica, etc. It's cool to be that dielectric medium. That is an insulating material in which all elements are tightly bound to each others. That is called to dielectric. Now the how many type of the dielectric medium? So molecules is a collection. We know that molecules of the collection of atomic nuclei surrounded by the cloud of electron. It is called to the what structure of atom. The proton and neutron in center and electron revolve around to this nucleus. Depending upon whether the center of positive charge and center of negative charge of molecule coincide or not, and it depending on two factors. One, polar dielectric and non-polar dielectric. Before we discuss about that, polar dielectric and non-polar dielectric, we discuss here about isotropic and anisotropic dielectric medium. Isotropic means what? If the property of dielectric material are identical in all direction, the direction is said to be an isotropic. The difference between dielectric permittivity along the director and permittivity perpendicular to the dielectric and permittivity perpendicular to the director. So now is the diagram is given that for LC between polarization and parallel polarization, cross polarization and parallel polarization. So both have the perpendicular to each other here defined. Now we are going to discuss about the question. Generally we know already we discussed about that point. So when positive negative charge, already we know that a neutral charge is center for positive charge and neutral charge is center in atomic structure. Electrons act as a negative charge and revolve around to the atomic structure, but they have not net dipole moment because that equilibrium condition. But when atom share electron pair to form of molecules, they maybe produce the polar or non-polar bonds. And as per the molecular structure that form the two type, the polar molecules and non-polar molecules. Now what is the non-polar molecules? So now the question arises, the first of all, the sum is hydrogen, carbon dioxide, oxygen, That is called to the what? Non-polarized. In non-polar dielectric substance, molecules are not polarized. They have not polarized. It means they have not polarized molecule. They have no charge attraction. They have there is no charge attraction. It means they have not attractive property. Non-polar do not contain permanent dipole. They have dipole equal to zero, and they have not alignment, and they do not produce electrical field. Obviously, the dipole has not produced the net dipole moment equal to zero and not permanent dipole. Definitely, electrical field will be zero. That's the reason. So now, based on these conditions, we say that uh, the dielectric, which is made of non-molecular molecule in center of positive charge and center of negative charge, already you see that H positive and CO2 O negative conditions and C positive condition. So these are called to be the non-polar molecules. Now we are going to discuss about polar molecules. That the second diagram is defined here. The second diagram is determined about. This is the H plus Cl minus, H plus Cl minus, O and H2O, H plus OH minus. So here in this diagrams, this is for the second diagrams is observe it is a polar molecule and above is a non-polar molecule. So what is the meaning of polar molecule? The polar molecule are dielectric or substance attract to electrical field because of electrical charge. Without electrical field, without I am talking about the absence of electrical field, they have moving randomly. They have not a particular direction. But when applied to the external electrical field on plate, the same polarity attract the molecules of observing here that this material permanent dipole moment. They have permanent dipole moment. The material is dipole or polar, but substances attract one another because the dipoles are opposite in a sign and equal in a small distance. The degree of alignment, here we have the question that alignment is depending on, but alignment depending on what? Alignment depending on temperature and also magnitude of field. Temperature increases, alignment decreases. Temperature decrease, alignment increases, field increases. H2O, NH3, HCl and alcohol. These are the example of polar molecules. In the very most important condition, due to this condition, when apply electrical field, the direction of electrical field is positive terminal to negative terminal. But dipole moment direction is what? Negative terminal to in positive terminal. It means opposite direction. Okay. So these are the example is given, and very most important condition, due to zero separation between positive and negative charge, the dipole moment such equal to zero. Therefore, this is for non-polar. But while we discuss about the polar molecule, due to that finite separation distance, they have the finite separation distance between positive and negative charge. Each molecule behave as the electrical dipole. Now, what the happen if the without electrical field, in absence of electrical field, dipole oriented randomly zero, and where consist of polar molecules or non-polar molecules. Here we are able to see in the diagrams and initially that non-polar molecule without external field. Here observe here uh, uh, center of negative charge coincide with center of positive charge. But in the situation when the external field applied, electrical field applied, that in the situation dipole moment, the P here negative terminal to positive terminal, and electrical field is moving for the positive terminal to negative terminal outer side on the surface. Now, as for the direction of polarizations, we say the polar molecule randomly oriented in the absence of external field while apply in the between two plates. When applied to the external electrical field, potential difference applied. That means molecule partially aligned with the field, and that's why I'm saying the align depending on the temperature and external electrical field. So now the questions arise in our mind. How does the create of polarization? The What is the polarization? The phenomenon of inducing a net dipole moment in any volume of the dielectric is known as the polarization. First of all, understand the definition is very most important. The phenomenon of inducing a net dipole moment in any volume of the dielectric medium moment dial uh, the phenomenon in net dipole moment in volume of the dielectric medium is known as polarization. The dielectric moment per unit volume, this dielectric condition is called to the what? Polarized. This dielectric is called to the polarized. The dielectric already we discussed. So net dipole moment equal to what? The net dipole moment in the situation equal to, as per the in condition of polarization, equal to net dipole moment divided by volume. So now we have the questions in our mind. So how does the behave of dielectric in an external electrical field? We already discussed. Based on this condition, how does the dielectric medium, polarization molecule and non-polar molecules dielectric medium, how does act in the external electrical field? In polar molecule, we are say that under that ordinary condition without external, we already say that the molecule have permanent dipole moment, but this randomly oriented. But it means no external effect is observed during the without external electrical field. But when the polar dielectric is external field is applied, the torque existed. What happened? Torque is produced. The torque existed on the electric dipole caused that to be partially aligned with the field. The degree alignment depend on the temperature, already we say that, and magnitude of applied external field. Align increases, temperature decrease, field increases. Alignment proportional to electrical field, but inversely proportional to temperature. Now we are going to discuss about very important condition. What happen when external electrical field is applied on conducting slab, if the conducting slab between to this charged particle? So now when, as per this condition, the dielectric slab, let me consider dielectric here, if diagram is given to conducting slab is between to this plate. So between the conducting slab is given, I'm not talking about dielectric slab, I'm talking about conducting slab. So in the situation is what, that the distance are very small, and here the condition is what, that as per the bound condition on the metal surface the free electron is movement, but inside that generally you are observing that electrical field is moving positive terminal to negative terminal, but dipole moment it moving to negative terminal to positive terminal. So in the situation when we calculate this value, that pose that q is one plate is positive and one plate is negative, and between the distance is d is given. So now the based on equation, based on this direction, that E net equal to E0 minus EP. So net electrical field equal to 0. But now we discuss about if we are put the dielectric medium. So what happened? Let's we check. If the dielectric slab between positive plate and negative plate, Uh, this plate is one is the plus Q and another one is negative Q. Now, based on this, get one positive terminal, one is positive, one is positive, positive terminal, positive terminal, positive terminal, positive terminal. Another is opposite side is negative terminal. Now, generally in outer field, we are put that dielectric slab between. We are put we put the dielectric medium between this slab. Of course, that outer side electrical field is terminal is moving toward to the what? Inside the condition is what happen? Yeah, here like the negative terminal is attract toward to the positive terminal, while positive terminal attract toward to the negative terminal. Now in the situation that electrical field is moving towards the what? Generally you know very well, positive terminal to negative terminal. That initially that at edge point outer side it moving from positive terminal to negative terminal. Same here, the positive terminal to negative terminal. But in the situation is what happened? It is when the two charged particles, positive terminal to negative terminal. Same here, positive terminal to negative terminal. Okay. Now the question, the which have the no charge, and here like example, this is the positive negative charge, this is positive charge. It moving to the directly on this charge. Same here, the positive and negative charge directly transfer from positive to negative charge. Now the question is arise in our mind. It is a dielectric slab medium. Now that is what electrical field. We know that it directly pass from positive terminal to negative terminal. But inside the condition that is a dielectric slab, so that's why we are writing minus E0 by K. Now why does that here is a negative, that is E0 by K, that is electrical field divided by substance, that is a dielectric substance value. Interpreted of this value of condition, the dielectric is placed an external electrical field, the dielectric is reduced. What happened? The first condition, number one condition, when dielectric is placed between external electrical field the electrical field within dielectric equal to 0. Reduce, not 0, that is the code, reduce. Now it has been found that the dielectric slab have relative permeability, therefore dielectric permittivity. K is placing. K is placing the electrical field E0. E0 by K in dielectric. Here is a negative plate, already we discussed. Now, now we come to on the important conclusion based on this condition. When an electrical field in air equal to E0, but in dielectric medium, if any dielectric medium between two plates, then E0 by K. K is the relative permittivity of dielectric medium. K is a relative permittivity of dielectric medium. The figures show that behavior of dielectric in where K is the figures show that behavior of dielectric in where K is the dielectric relative relative permittivity of medium. That besides the figure is shows that behavior of dielectric in electrical field of parallel plate air capacitor. So electrical field in air is E0 and become E0 by K in the dielectric. So dielectric field is reduced. Electrical field is reduced by factor K in the dielectric in a increasing form. Now we discuss about to be the some definition. So what is the relative permittivity? Already you learn about to be the relative permittivity in first chapter. ER equal to E upon E0. It means that is the relative permittivity ER. But net electrical in the capacitance condition E minus E0, the net equal to initial, that EO and E initial. It means that electrical field equal to what? That original electrical field, that initial, divided by how many electron electrical share after the share of electron value. Now E equal to now E equal to E0 minus EI. Therefore, in form of dielectrical condition, E0 divided by E. It is called to the what? Applied electrical field divided by net electrical. Based on these equations, we know very well that surface charge distribution, that E equal to E0 equal to sigma upon epsilon 0. Number 2, E equal to E0 by K, Ek equal to sigma by K, E0. Now sigma upon K times epsilon 0 equal to sigma upon epsilon 0 minus sigma upon epsilon I. Therefore, sigma I equal to, when we calculate the value, the K minus 1 divided by K into sigma. K is always greater than 1. That induced charge density is sigma I on dielectrics. Therefore, sigma I is dielectric is less than the free charge density sigma. Less than free charge. Dielectric is always the induced charge sigma I on the dielectric less than the free charge density. So based on these conditions we know very well, like sigma equal to, I'm talking about the k equal to 3. If we take example, if k equal to 3, then what is your answer? The sigma I equal to k into 3 minus 1 upon 3 into sigma, the 2 by 3 sigma, that k equal to what? If k equal to 1, then sigma equal to 0. For sigma k equal to infinity, then e tends to 0. So sigma I equal to 0. Thus means that surface charge induced on conductor equal to equivalent opposite that on the plates. In the field of 0, in the 0 conductors. Now the second definitions we discuss: polarization density. What is a polarization density? Polarization density means what? The induced dipole moment developed per unit volume. In a dielectric slab or polarization and placing inside electrical field. In the P equal to P proportional to P proportional to equal to alpha E0 E0, P equal to for n terms n into alpha E0 E0. The volume slab A into L. So therefore polarization density equal to P equal to sigma A into L upon AL equal to sigma I. This is called to the polarization. So as per this conclusion, what we understand? What we understand based on this concept? We understand about the induced dipole moment developed per unit volume is called to the polarization density. And the last definitions of this topic, electric susceptibility. The susceptibility is equal to what? The polarization density of dielectric slab is found to directly proportional to reduced value of electrical field. So therefore the P equal to chi E into E. The constant proportionality the chi equal to constant proportionality constant proportionality and based on proportionality is equal to the electrical susceptibility. It is equal to the what? Electric susceptibility. Okay, now we are going to discuss about what? So here we discuss about the dielectric strength, and based on the dielectric strength we are discuss about, and then after we discuss and then we are going to discuss about to be the when the capacitors is between to the dielectrical slab. It is very important condition. Yes. So what is a dielectrical strength? Based on conditions we learn about dielectrical strength. It is very important. So if we understand this concept, definitely we easily solve out to the problems of capacitors. So dielectricals is what? The degree of polarization of the dielectric depend upon the intensity of electrical field lines. Field, of course, and that applies to the dielectric material. As the field intensity increases, the polarization of dielectric field intensity, here the electrical field increases, the dielectric polarization increases, as well as till the stage reach when the electron pick up. When electron pick means in a break situation up from the molecules of dielectric. At the stage, the insulation of dielectric break down. I repeat again, that degree of polarization is depending on what? Depending on polarization of dielectric depending on intensity electrical of field. So electrical field increases, intensity increases, dielectric polarization increases. But up to which stage? Till when the electron break up from the molecules of the dielectric. When the electrons break up from the dielectric molecules, the insulation of dielectric is breakdown. The nature of charge, the nature of dielectric change from insulator to, and in that situation, when the breakdown, the dielectric, it convert into the conducting material. As electric breakdown, the spark process produced passes through the dielectric medium. So the maximum of electrical field intensity, that's why saying the maximum value of electrical field intensity can be applied to dielectric without breakdown. It's called to the dielectric strength. It's a last border, last strength, the last line. After the breakdown, it convert into the conducting medium. So generally, how does the measure to dielectric strength? The dielectric measure is measured in kilowatt per millimeter. It measure in kilowatt per millimeter. So generally, in commercially we understand the dielectric medium. The dielectric medium. 1 minute. Uh, the dielectric strength. Its value we discuss about that 30. Generally, dielectric strength is 30 kilowatt per centimeter. Now it means that maximum potential difference. What is the meaning of that? The maximum potential difference that 1 centimeter thickness of air can be withstand across the with electrical breakdown is 30 kilowatt. What is the meaning of that? The potential difference of maximum potential difference that 1 centimeter of thickness of air can be withstand across across it without breakdown is 30 kilowatt. The value of dielectric strength of insulator depend upon temperature, solid we discussed, moisture content as well as shape, etc. The electrical field intensity the electrical field intensity the electrical intensity, potential gradient and dielectric strength are symmetrically equal, and therefore the reason for safety. Now we are going to discuss about capacitance, because here we learn about what? The dielectric medium. So now the situation is the capacitance of parallel class between dielectric slab. Now we discuss about what? Capacitance oriented. The capacitance means what? So now the C equal to Q upon V, and based on this equation, Q is a charge, Q by V, that is a charge upon voltage, and unit of the capacitance is Faraday. If the charge is in the form of, it's a produced under two type, series and parallel. In grouping, we discuss about with the capacitors in the group form, it's a series and parallel combination. If the series form, if we think about that, it is produced in the series, its formula, that in the situation we discuss about that V is a different, V1 plus V2 plus V3. Q is common, charge is common, and C is a different, C1 plus C2 plus C3. So in the situation V equal to, for the series connection, if the if the capacitors are connected in the series in electrical circuit, based on this condition, the one is a positive charge, another is negative, one is positive, another, but all have the magnitude are the same. So V equal to V1 plus V2 plus V3 equal to Q by C1 plus Q by C2 plus Q by C3. Q is common, 1 upon C1 plus 1 upon C2 plus 1 upon C3. But we know very well the V upon the Q is moving to the left side, and the situation the V by Q equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, and V by Q equal to what? That is obviously the Q by V equal to C. So based on these equations, we are saying the 1 upon capacitance in serial form, in series condition, 1 upon C1 plus 1 upon C2 plus 1 upon C3. So therefore, if for two capacitor connect in the series form, the CS equal to 1 upon C1 plus 1 upon C2 plus 1. That for the 1 upon C2, the C1 into C2 divided by C1 plus C2. Same we discuss about parallel capacitor. They are connecting the parallel. It is a plus Q. In the charge is different. Positive charge, negative charge Q1. Positive charge Q2, positive charge Q3, negative charge Q2, negative charge Q3. Based on these diagrams, we say that the capacitors in the Q is a different, Q plus Q2, Q3. But voltage is common. The same voltage and potential difference is applied in the circuit, and therefore, based on the equation, the Q by V equal to C1 V plus C2. Yes, the Q equal to C1V, C2V, C3V. Capacitors are different. V common, we are taking to the common of voltage C1 plus C2 plus C3, and Q by V equal to C1 plus C2 plus C3. Therefore, Q by V equal to, already we know that is called to the parallel capacitance. Here the Q is capacitance value. Therefore, C1 plus C2 plus C3. Based on this value, we have find that parallel capacitance C1 plus C2 and C3. So what are the difference between parallel capacitors and series capacitors? That parallel capacitors is connected parallel and they have potential difference are the same, but in series capacitors that charge current, the charge flow in the circuit is the same. Now in this condition, the net effect of connecting capacitor in series is decreasing capacitors, while net effect of connecting in parallel capacitor is increases in the capacitors. When capacitors are connected in series form, the charge is same on each capacitor, already we discussed, and C by Q equal to Q by V for the series connected capacitor is Q is the same, so that V proportional to 1 upon C, and for parallel capacitor V is same, that Q proportional to C. That's it. Let's see the video so we understand how does this work capacitor in electrical circuit. Let's understand how does the capacitors work in capacitors. Please see the video.
In a metal conductor, the positively charged particles are fixed in place, whereas the negatively charged particles, called electrons, are free to move around. A metal typically has an equal amount of positively and negatively charged particles, making the metal as a whole electrically neutral. If we apply a force trying to push extra electrons into this metal plate, we will not be successful, because particles with the same charge repel one another. If extra electrons accumulate inside the metal plate, they will repel each other and repel any of the new electrons trying to enter. Therefore, even if we apply a force, the metal will remain electrically neutral. Now let us consider a new scenario where there is another metal plate close to the one shown. As electrons accumulate in the first metal plate, they will repel the electrons in the second metal plate. The positively charged particles left behind in the second plate will exert an attractive force on the negatively charged particles in the first metal plate. This makes it possible for the first plate to have more negative particles than positive particles. As we add electrons to the first metal plate, an equal number of electrons leave the second metal plate. After a certain number of extra electrons accumulate on the first plate, they will repel any new electrons trying to enter. The first metal plate has developed a net negative charge, and the second metal plate has developed an equal and opposite net positive charge. We can cause this equal and opposite charge on each plate to be larger by applying a larger external force. If we remove the external force we are applying, the extra electrons in the first metal plate will continue to repel one another. We have now returned to our original condition where the net charge on each plate is zero. The two metal plates are what we call a capacitor. Note, voltage is shown upside down in this video because the blue arrows will show electron flow. By briefly connecting the capacitor to a battery as shown, the two plates have developed equal and opposite charges. If we then connect the capacitor across the light bulb, all the extra electrons in the negatively charged plate will move to the positively charged plate through the light bulb. If we use multiple batteries in series, then we can force the two plates of the capacitor to develop larger amounts of charge. When the capacitor is charged, its voltage will be the sum of the voltages of all the batteries. Charging the capacitor to a higher voltage will cause the light bulb to stay on longer when the capacitor discharges. Now suppose that we increase the areas of the two metal plates. This increased area allows us to push more extra electrons into the first metal plate and remove more electrons from the second metal plate without applying a larger external force. When a larger capacitor is connected to our battery, it'll take longer for the capacitor to charge to the voltage of the battery. Although the final voltage is still equal to the voltage of the battery, for a larger capacitor, this voltage represents a larger amount of charge on the two metal plates. The larger capacitor will take longer to discharge through the light bulb, thereby allowing the light bulb to stay on longer. Suppose that we add a special material in between the two plates. This material does not allow any particles to flow through it, but it contains molecules that change their orientation based on the charges of the two plates. These molecules exert forces that attract more electrons to the negative plate and that repel more electrons from the positive plate. The presence of this material has the exact same effect as does increasing the areas of the two metal plates. This allows the two plates to develop larger net charges for the same amount of applied voltage. We say that we've increased the capacitance of the capacitor. There is also a third way to increase the capacitance of a capacitor.
In the distance very close to each other.
This is by moving the two metal plates closer together. Because the two plates are now closer together, they exert greater forces on each other's electrons. This attracts more electrons to the negative plate and repels more electrons from the positive plate, allowing the two plates to develop larger net charges for the same amount of applied voltage. This has the same effect as inserting the special material and as increasing the areas of the metal plates. To create the largest capacitance possible, we want to make the areas of the plates as large as possible, insert the special material in between the plates, and move the two plates as close together as possible.
So based on these conditions, we learn about what? We learn about that capacitors is depending on its area, the reluctance value, that how many voltage applied, as well as distance, and very important conditions, power supply. It means the voltage is increases, the capacitance is increases also. So now we just solve the one numerical, so we understand more this concept. Like I draw the diagram, it is very important. Here the C1 and here the C2 charge given, uh, the C3 charge is also given, C2 and C3, and here is a C4 charge. Okay, C1 equal to 3 microfarad, C2 equal to 9 microfarad, C3 equal to 9 microfarad, and C4 equal to 9 microfarad is given. It is a network for the capacitors. Determine the equivalent capacitance between point A and B. So we have determined here A point, and this is called to the B point. We find to the point A and point B capacitance value, equivalent capacitance we want to find. And if the 10-volt battery applied in connected between A and B, how much total charge is stored in this capacitor? So first of all, we find that this is the, in the situation, the 3 in series form and 1 in parallel condition. So first of all, we have draw the diagram properly. That is, the C1 is parallel in terms of C2, C3 and C4. In the situation A and B, as per the point we want to find the A and B, the C1 is parallel way to C3, C3 and C2, C3 and C4. C2, C3 and C4 in parallel situations, as per the series capacitance we know very well, 1 upon C2 plus 1 upon C3 plus 1 upon C4 is equal to 1 upon 9 plus 1 upon 9 plus 1 upon 9. It means equivalent value is 3 by 9. It means 1 upon 3. Series equal to 3 Faraday. It's a microfarad. Okay, series in the first conditions we know very well. Now we want to find that A and B, between we want to find the between A and B. So therefore we want to find capacitor, net capacitance equal to Cs plus C1 equal to 3 microfarad plus C1 has also 3 microfarad, total 6 microfarad. Now we know the answer, the C, net C we get the value. But we want to find how many charges stored, that Q equal to C into V. Net equal to what? 6 multiply voltage 10. Answer is 60. But very important condition you need. Therefore, 60 microfarad, 60 into 10 raised to minus 6 farad. This is not wrong. See here, it is the answer is 60 microcoulomb. The charge unit is coulomb. 60 microcoulomb. It is that coulomb. That Q equal to, we are getting 60 microcoulombs. We are getting that total charge is stored. Thank you.